Okay, so welcome to this second session on the series of lectures on data mining and information retrieval. First part is on data mining and the second part is on information retrieval. We covered an introduction last week, and we were able to look into why we use data mining and motivation for data mining and different ways of looking at data mining. So today we will take the first topic. As I explained in the introduction, we jump from chapter 1 and 2. We covered chapter 1 and 2, and we'll jump to a later chapter so that we get to look into some of the data mining techniques and then come back to the other stuff like the data pre-processing and data warehousing, the topics that are in between the first few chapters and these chapters, right? So we will cover association rule mining today, and next week we will cover data classification prediction, and then maybe in 2 or 3 weeks we will cover clustering, the key major areas in data mining, right? And as I said earlier, we use the book by Jiawei Han and a few others on data mining concepts and techniques, and most of the slides are also based on the book slides that are used. Right, so let's talk about association rule mining. I think I alluded to this example slightly during my introduction to data mining, but this is a very classic example where in supermarkets, people have found that beer and diapers are bought together by a lot of people, right? So, and why? I mean, they find, using data mining techniques or pattern mining techniques, they have been able to find that beer and diapers are bought together. And how could they be related, right? So actually from a data mining point of view, how they could be related is not that important. But if you find that these two unusual items are bought together, because if something is bought together, usual items like bread and butter are bought together, that's obvious. We will always make sure that things are kept together in a supermarket because we know that. But here it's an unusual pair of items that are going together. What could be the reason for people to buy this together, right? So, and how do we find out? We can find it out by looking at the basket of items that people buy at a supermarket, or most of the people buy, right? So if we analyze the basket of items that people buy, and if we try to find the most frequently bought items together, we will be able to find these patterns. And as I said earlier, this is an unusual pattern, right? So my first question was, why would people want to buy these together? Right, so yeah, as I said, it's not that important, but if you dig into, if you try to look into some intuition as to why people would buy these together, a reasoning can be given that people or guys would have to maybe do babysitting, and to do babysitting you need diapers, obviously, because you need to change with the small children or small kids or small babies, and then to keep themselves occupied, maybe they want to have a beer also, right? Anyway, right, so that is an outcome of association rule mining, and let's look at how we can dig into large volumes of data that is available in supermarkets and find these types of associations among data items, and then make use of those associations from a business point of view, right? So from a business point of view, finding out that there is this unusual pattern together, what we could do is we could do some strategic placement of items, right? So we can maybe place some diapers near where we sell alcohol or beer, or the other way around. Maybe where we sell diapers, we can maybe keep a few cans of beer, or I mean, some temptation for them to buy that, right? So that when they come and buy, one thing, it's making it easier for the customer to find items that they want, and also If you forgot to buy, you get reminded that you need to buy, right? So this is called cross-selling, cross-marketing, right? So those are things that we can do. But to do that, first we need to find out these patterns, right? And in this case, it was a very unusual pattern. And this is actually used as a very classic example when they want to show the motivation for data mining. And it is said that Walmart, one of the pioneers in data mining, at that time they didn't even realize or know that they were doing data mining. This was one of the patterns that they identified, and they were able to use these patterns to take advantage of identifying these patterns and making better decisions in how they go about in doing their business. Yeah, so for this session, the idea is to be able to, I mean, at the end of this session, you should be able to describe what are the fundamental concepts of association rule mining, especially when it comes to large data sets. We're talking about large data sets and how we extract these association rules. Yeah, and then I mean, the concept, and then how do we do it? There are multiple algorithms to do it, and there are multiple stages in this process, right? So you should be able to explain the process or the various stages, and then explain the computational challenges, because we are talking about data mining, right? It's not a piece of cake. Sometimes when you are talking about large volumes of data, and then we are talking about large I mean, algorithms that are having very high time complexity, right? So how do you handle it, right? So that's a challenge, and especially as people, as students who are doing computer science and engineering, going out, you should be able to understand these challenges and then think about solutions, and what are the solutions that the industry is using, what are the solutions that the research community is suggesting, and then what can you do to maybe do it better, right? But at least first you need to understand the computational challenges, right? And then you should also have the capability of evaluating the choices that are available, right? And based on those choices, you should be able to select an appropriate approach if you are required to run an association rule mining algorithm on a given data set, right? Yeah. Yeah, so as the lecture outline, we'll talk about the basic concepts, then we'll talk about efficient and scalable ways of doing frequent item set mining. It might be a new term when I say frequent item set mining, but what we mean by that is identifying patterns, right? Frequently occurring patterns. Yeah, and then there are variations to the kind of associations that from the patterns we create associations, right? So there are various ways of associations that we can find, right? So we'll talk about them. And then what is the relationship between association mining and correlation? We already know about correlation, right? So we'll talk very briefly talk about that. And then we also talk about extensions to association rule mining, right? With respect to adding constraints into the way that we do the mining, and then getting results that you want, rather than just getting general results. We put a constraint, and then maybe we can get exactly the result that we want, right? And then we have a small summary. Right, so what are frequent patterns? Right, as the term says, frequent patterns. It's like frequently occurring patterns. Right, so there are patterns, right? I mean, in data, you always get patterns, right? So out of those patterns, are we able to identify the most frequently occurring patterns, right? So that's what we are looking at here, right? Right, in a given data set, what are the most frequently occurring patterns? If, I mean, from a business point of view, these most frequently occurring patterns mean something, right? That means it's happening most of the time, right? So we can take advantage of that, right? So that's what we are trying to do here, right? And this finding the frequent item sets or frequent patterns, and then within those frequent patterns, are there any associations, correlations? Looking at that was first introduced by Agrawal a long time ago, in 1993, right? I mean, from an industry point of view, it's not that important, but from a research point of view, it's always important to figure out from where things are coming, right? Yeah. So what was the motivation? What was the motivation at that time, and what is the motivation today for us to continue to work on this frequent pattern mining, and then from those patterns to try to identify some associations among these attributes that we have within these frequent patterns, right? Yeah, so I think we already saw that example of products that people buy together, right? So beer and diapers, right? And so many other combinations of products that people buy together, right? So we can do that by first identifying the frequently occurring patterns, and then from that we can try to see whether it's a case of a person going for a beer, buying a beer and then looking at a diaper, or whether first you buy a diaper and then look for a beer, right? So that is what we mean by association. It's not the pattern. Pattern is just the two items only, right? So that's one motivation. What are the same as what I said earlier, right? So you buy a PC, and then after that, what would you buy? Would you buy a printer or a dongle? In Sri Lanka, people might be buying a dongle, right? So frequently, what is the next purchase that you're going to make, right? Right. So that is not only for physical stores. I mean, Amazon and so many other online stores are using it very heavily to figure out when you buy something, what would be a typical customer, what is a typical customer going to buy next, right? And then maybe you should put some advertising for you, specifically targeted for you, right? Yeah, so I don't want to go too much into detail about bioinformatics, but people who are doing bioinformatics already know that our DNA has a lot of information, and this DNA, within the DNA, we have loads and loads of patterns, right? So we can use frequent pattern mining to identify frequently occurring patterns, and then maybe try to figure out how a certain drug affects certain people, or how a certain a certain gene might affect a certain characteristic. All those things can be found, right? Yeah, so web documents also very similar, right? So if you look at the click stream of people, right, you can find out from which website to which other website you go, from that to which other website you go, right? So based on that, you might be able to figure out, okay, next you might be going to this website, right? And next you might, right? So rather than letting the user decide, or you can suggest certain links that you want your client to look at, right? Yeah. So there are lots of applications for this thing that we are talking about, what we call frequent pattern mining, or frequent pattern analysis, or association rule mining, or market basket analysis, right? So basket data analysis, cross marketing, catalog design, right? So earlier we used to design one catalog and print thousands and thousands of copies and give, but nowadays we don't do it. Now we actually design catalogs for the market, right? So that can be done by analyzing market segments, right? Figuring out frequently interested items for a group of people, right? So that is a possibility. Yeah, sales campaigns also. Nowadays we do targeted sales campaigns, right? So to do targeted sales campaigns, we need to find frequently occurring interests, right? Yeah, so I think the rest of the things are straightforward. If you read it, you can figure out what we're talking about. Yeah, so why is frequent pattern mining important, right? What we're trying to do is we're trying to disclose some of the intrinsic um, properties of the data sets, right? So some of the relationships among the data items that we have in the data set, right? So that's what we're trying to do, right? Right. So yeah, so this frequent pattern mining actually forms the once again, don't get it confused. Frequent pattern mining is the first step, right? This next step, frequent pattern mining means when you are given a data set, we're trying to find out the patterns that are, I mean, you might be wondering why you need to think so sophisticated about this, but when you look at the data set, you'll figure out why we need to think about this, and we need algorithms to do this, right? But the first step is to try to figure out what is frequently occurring, right? So once we identify what is frequently occurring, there are a lot of other things that we can do. Then after that, we can try to see with these frequently occurring patterns, are there any associations or correlations? Are there any causality, right? When you do this, this happens. When you take this drug, this will happen, right? So that is what we mean by associations or correlations or causality, right? And then, yeah, right? And then this can also be used in analyzing graphs, right? So first of all, analyzing subgraphs within a larger graph that is frequently occurring, right? And then once we find that, we might be able to find any correlation among those subgraphs, right? Yeah, pattern analysis of spatiotemporal data, multimedia, time series data, stream data, all those scenarios where the data is coming in a stream or in a rapid pace. What we could do is we could try to run a pattern, frequent pattern and mining algorithm to identify the frequently occurring things in the stream of data. And then on top of that, we might be able to find associations. Right, we have not done classification yet, but when you do classification, I don't want to define classification because in the future we'll be doing, right? So some of you may be just having an idea about classification, right? So for classification also, just for the moment, take it from me, we can use this frequent pattern mining and association mining to come up with classification algorithms, right? So that's a possibility. Cluster analysis also, once again, we have not done it, but you know what cluster analysis is. Cluster analysis is trying to, if you're given a data set, trying to put them into groups, right? So frequent pattern mining can help you to first identify these frequent patterns and then maybe group them into clusters, right? So that's what can be done, right? So in other words, frequent pattern mining is quite an important area in data mining that is being used in multiple applications. Right, so let's get to the basics of frequent pattern mining or associations. Right, so I give you a small data set. Once again, with this small data set, you might not realize the gravity of why we need to spend one whole day looking at algorithms, right? But just first of all, I understand the concepts by taking this very, very small toy example. Right, so in this toy example, first of all, we'll try to understand the data set, right? So we have a set of transactions. We can consider this as a set of transactions that took place in a supermarket, right? So you go to the supermarket, I mean, 5 people go to the supermarket and they buy different items, right? So in this supermarket, we only have A, B, C, D, E, F items, right? Very limited set of items, right? But remember, in a standard supermarket, you get millions of customers or maybe 10 million customers, and then the items would be about 100 to 200,000, the inventory of items, right? So that complicates the problem, but for the moment, we'll look at it like this, right? So yeah, right. So item set. Yeah, so I mean, if you look at a bit of a definition, what we can say is that we have an item set that goes right. So that those are the items that we have, right? And what we want to do is we want to find out whether there are any associations or rules among these item sets that we have, right? So for example, if from this data set, can we say that if you buy A, you are also going to buy B, right? Right. So that's what we are looking at, right? And to do that, I mean, I mean, you already have done what do you call this conditional probability, right? So actually, we are using simple conditional probability. Once we know that there are 2 items that are frequently happening, right? So to find out whether an item is frequently happening, we use a measurement called the support, right? So in that, what we try to do is we try to see where I mean how many times a given collection of items are being a given collection of items are there in a given transaction, right? So for example, just look at this example. If you take AB, no, we'll take yeah, AB, they're in first transaction. Again, that's all we have, right? So that means support is 1/5, right? So out of 5 transactions, we have only one transaction where we have AB together, right? Right. So that's a support, right? And then confidence is this conditional probability, right? So if A happens, what is the probability that B is going to happen, right? So we can give the conditional probability by taking the support of AB happening divided by the support of uh, A, right? If you want to look at the conditional probability from A to B, right? So yeah, if you look at this example, you see, unfortunately, I can't use any annotation when I use this mode of presentation, but I hope you're following what I'm trying to say, right? So yeah, so let's take this example of A and D, right? So first of all, we need to find out how many times A and D are occurring, right? Right. So we are not looking at the algorithm. Don't take this as the steps in the algorithm, right? So A and D is occurring how many times? 1, 2, 3, yeah, 3 places, right? So what is the support? A for AD, the support for AD is 3 divided by 5, that is 60%, right? And then for DA is also, I mean, the same thing, but when it comes to the conditional probability or the rule, association rule, it's different, right? So, for AD, what would be the conditional probability? AD, support of AD is 60 divided by support of A, right? What is the support of A? A is only occurring again in 3 places only. 3 divided by 3 is 100%, right? Other way around. DA, what is the probability of, support of AD is once again 3 divided by, or I mean, we can talk in terms of percentages or numbers, right? And then divided by the support of D, right? How many times D occurring? 1, 2, 3, 4 places, right? So therefore, it is 3 divided by 4, that is 75%, right? So there is a difference, right? So that is those are the basic concepts of association rules, right? So I'm also showing in that example, I mean, the Venn diagram, how it is, how we can think about this, right? The customer who buys beer, I mean, I'm not using AB here, but customer who buys beer, customer who buys diapers are there, and then there is these customers who buy both, right? So what once we identify that the beer and the diaper case, then we can look at how we can figure out whether the customers who buy beer buy diapers or with a higher probability, or customers who buy diapers buy beer with a higher probability, right? So in this case, we would say that A implies D is a more confident rule than D implies A, right? Because there were 4 people who bought D and then went and bought A, but the other way around, when you buy A, there is a 100% chance that you will buy D on the data set. That doesn't mean the next customer will do the same thing, right? Yeah, talking in terms of probability, right? Guys, if you have any questions, please ask, right? Right, now let's look at, I would have liked you to take a piece of paper and think about an algorithm to do this. How to find these frequent patterns? How do we find these frequent patterns? So let me allow you to think of for a moment, because you're all computer scientists. You have done algorithms, you have done data structures, right? So think about for a moment and see how would you find these I mean, you might think, why not you put it into a small list, the items in a list, and then maybe go through these transactions one by one, counting the occurrences, right? So that might be a way of doing it, a brute force approach of doing it, but it's a little bit complicated when you have 100 million customers and maybe 200,000 items, right? And these 200,000 items also, one person is not going to buy 200,000 items. It's going to be maximum 10, 15 or 20 items a person would buy, right? Right. So yeah, so therefore we need a slightly better approach, right? So there are multiple approaches. Let's look at a few approaches, right? And as examples of how we can do this, right? Yeah, so we use something called the downward closure property to identify these frequent frequently occurring items, right? Once again, I'm eluding the problem. What is the problem? We need, out of a given data set of transactions with multiple items, we need to find the transactions that are frequently occurring. Right, so I did not, in the previous slide, I did not say about what we would consider as the minimum support or confidence, right? There is on this slide, there are two terms saying minimum support and minimum confidence. Yeah. So when you do frequent pattern mining, when you do association rule mining, that is something that you need to set. We need to tell the algorithm, or we need to set that. Otherwise, we don't have a basis to say frequent, right? To say frequent, what is the threshold, right? So in this case, we are saying 50%. Otherwise, we would end up getting all the rules that are there, right? We don't want that happening, right? Some of the rules we don't, I mean, anything that is below 50, we are not interested in, right? Confidence, in this case, we are also saying 50%, right? So yeah, so now what we need to find out is, first step is to identify all the patterns that are having a support of more than 50% in this previous example, or a given percentage, right? So how do we do that? Right, so we use something called downward closure property, which is explained in this one. What it says is that, take this example of beer, diapers, and nuts, right? If we are going to have beer, diapers, and nuts as a frequent pattern, obviously beer and diaper should also be frequent, right? Otherwise, we would not have. Beer and diaper should also be about, I mean, let's take that example of 50%. We want beer and diaper to be more than 50% frequent. Beer and diaper by themselves also should be 50%. If beer and diaper is less than 50%, there is no possibility that beer, diaper, and nuts are going to be 50%, right? It's obviously going to go lower than what we have, or equal or low, right? Yeah, so that's what we use, and we can extend that to the next step, right? So to say that beer and diaper is 50%, beer on its own and diaper on its own should also be more than 50%, right? So that's what we use here, right? That's based on the downward closure property, right? So if you look at this example I have shown you at the bottom of the slide, for ABD to be frequent, BD should be frequent. And for BD to be frequent, B as an individual, D as an individual should be frequent, right? So if you look at this slide, and if you find that it's only A, B, and D are frequent, or maybe we can say A, B, C, D are frequent, then we can limit the search to anything of those combinations, right? Anything beyond these four items, we'll never find them to be frequent, right? So that's we call it the trick that we use to find these frequent patterns, right? So yeah, so as I said, there are multiple approaches, multiple research papers, multiple people have written. Apriori is one of the earliest. I told you, Agrawal is the one who came up with the one of the first research papers on association mining. Right? So apriori is the algorithm that is used, which is not very efficient, but it's better than a brute force approach, right? And then we have another one called pattern growth, which is a little bit better, written by these authors of this book, right? And then we can extend that a little bit further to go into other ways of doing it, right? So we are not going to talk in detail. We are actually going to talk about the first two in detail. Third one very briefly, right? Yeah. So a priori pruning principle. We already discussed about the a priori pruning principle, right? So it's a case of starting from the bottom and then building, adding until we cannot add anymore, right? So we start with one items, right? We look at the count of one items, right? So whether an item by itself is frequent. If that item is by itself frequent, we keep it. Otherwise, we ignore all the other items, because we are not going to have any frequent pattern created by adding any other item into this if it is not frequent by itself, right? So this algorithm, if you look at this algorithm, you can see initially we scan the database to find the one frequent item source, right? And then we combine them. I have another slide in the next slide where I go through an examples, but for the moment, just try to see whether you can understand the steps in this algorithm, right? So we add, I mean, I said we first identify the frequent one item. When you say frequent, remember for this algorithm, we have to say what is the minimum frequency, right? So our example earlier, we had 50%, right? So it has to be at least 50%, right? Yeah, so once we identify the one item frequent pattern, items, we add them together, we combine, we add one more item together and then do another database scan to check and see as together whether they are frequent. If they are frequent, we keep it. If they are not frequent, we throw them out, right? We throw that combination out, right? And then we keep on adding, we do that for all the combination, right? And we terminate this when we, I mean, once we have the 2 items, then we make it a 3 item set. After that, we make it a 4 item set, right? We will stop this when we come to a point where we can't add any more, right? We don't have anything to add, right? So that means we have exhausted the possibilities. Right, very quickly we'll look at this algorithm. I request you to closely follow the follow how it is working. Hopefully my face will not cover the slide. I will remove my face if that happens, right? So yeah, first of all, once again, we have the same data set. In this case, when we talk about support, we are talking about support in terms of items, right? You can talk about support in terms of items or probability or percentage, whatever, right? Right. So that when you say minimum support of 2, that means for us to take an item to be frequent, it has to be there at least in 2 transactions out of the 4 transactions. That is, in other words, 50%. Right. So we scan the database once and identify the items that are frequent, right? At least that item is there in 2 transactions, right? So if you look at that, we see 2, 3, 3, 1, 3, right? So and D is the one that has only 1. I mean, if you look at the data set, you see it's only in the first transaction, right? So we drop it. We don't think about D again because it's too small for us based on the minimum support that we have. Right, so we filter out that and we end up getting A, B, C, D, A, B, C, E, right? Then what do? We need to look at the combinations. We look at the combinations of AB, AC, AE, BC, BE, CE. So I said this is not the best algorithm, but this is the first algorithm that people came up with, right? And it works, right? Right. So now what do? We do a scan again, right, to find out whether these combinations are frequent, right? If you do that, we end up getting this result here, right, where we find that AB is 1, AE is 1, but the rest of the combinations that we checked are at least 2 or above. Right? So we keep them. Now what do? Yeah, well, now what we need to do, sorry, I show the items that we are keeping, right? Now, what is the next step? Next step would be to, yeah, I'm not covering. Next step would be to look at the 3 item combinations, right? So AC, BC, BE, CE, right? So how about we take AC, BC together? AC, BC together will create ABC, right? We can check that. Then what about BC, BE, BC and BE? We take BC, BE together and make a BCE combination, 3 items set, right? Then we have BE, BCE, yeah, it's already there, right? So I don't show, in this example, I don't show the frequency, but what we see in this example is that BCE is the only combination that we have with the support of 2, right? Right. So if you look at the data set, you see BCE is there in second transaction, BC is there in the third transaction, right? 2 and 3, right? So therefore, we end up getting a support of 2. And so that is the only one, right? So we don't have to go any further because there's no way of adding anything more, right? Right. And also there are a few other pruning techniques that we use, right? So for example, when we combine AC, BC together, we say ABC, right? Right. When you do that, we check to see if any one of those sub-combinations are low frequency, right? So for example, when you say ABCE, right, ACA, we create AB, ACA, sorry, so confusing you. with AC and BC, we can create ABC, right? So in that ABC, you have a AB sub pattern is a AB, right? And we know that AB is 1, right? So obviously ABC is going to be less than the required frequency, right? So we don't check ABC, right? I just gave you an example, but I'll formally show you that as part of the algorithm. Right? Any questions? Is it clear? Yeah, I'm going a little bit fast because I want to do some activities. 3 activities are there on the Moodle, right? So if you are just following this on your mobile, you better get your PC or laptop and log into the Moodle, right? Right. And hopefully this is understood. Right. Very briefly, we'll look at what we did, right? In generating the candidates, right? So step 1 is what we call self-joining. We join the remaining candidates. We call these we call these items that we select as candidate. Initially, everybody is a candidate, right? And then based on the frequency, we drop some of the candidates, and then potential candidates are there, and then we, by scanning, we check and see whether these candidates are valid. We can go any further, right? So that's what we do, right? So we do a self-joining, and then we do a pruning, right? By doing the scan, we can figure out, okay, these are not, even before doing the scan, sometimes we can do it, right? Yeah. Yeah, so we count the support of the candidates, right? Yeah, so this example, we have an example of how we do the candidate generation. I tried to explain it with the previous slide, but this is much more clearer, right? So L3, level 3, right? Let's say we have ABC, ABD, ACD, ACE, and BCD, right? And so as I said, we do self-joining, right? Self-joining of the set that we have, right? So from that, we end up getting ABCD from ABC and ABD. ACDE can be got from ACD and AC. We are just showing a few examples, right? But we can do even without doing a scan, we can do a pruning, right? What is that prune? We can remove ACDE because a sub pattern is ADE, right? For ACD, I mean, possible sub patterns are one of the possible sub pattern is ADE. And we know that ADE is not in our set, right? We have ADC, ABD, ACD, ACE, and BCD, but ADE is not there. Therefore, we can remove that. Right? Then we say that we only need to scan for ABCD. I mean, there is no cost for scanning unnecessary ones, but because anyway, the biggest cost in scanning is to get the data, right? But why should we look for something that we know is not going to be there, right? Yeah, so what are some of the challenges in frequent pattern mining? Right, so one of the biggest challenges that we have is that multiple scans, we have to do the multiple scan of the database. I already alluded to that, right? So scanning the database, getting the data. Nowadays, we have in-memory databases and so lots of things, but still, even with in-memory databases, scanning the database, large database, I mean, even with the in-memory database, if you talk about the sizes of these data sets, we can't think about putting it and doing it, right? So that's the biggest problem, right? And then with the self-joining and the things that we do, we generate a lot of candidates, large number of maintaining the list, maintaining the counts can be very tedious, right? Yeah, it's very tedious to keep the support counting of the candidates, right? So there are a few improvements that people have thought about. As with always, when there are problems, when there are challenges, people come up with solutions, and that is how we generate papers, right? So those who are interested in research and development, think about these challenges, think about these problems, and see whether there are ways of improving it, right? Whether there are ways of fixing the problem and giving a better solution that will give you a patent, or that would give you a product, or that would give you a research paper, right? Yeah, so general ideas are trying to reduce the passes of the transaction database, right? maybe try to shrink the number of candidates that you need to check, right? And maybe facilitate support counting of candidates, right? So can we have a secondary data structure that can help you to do the candidate counting rather than having to do the candidate counting by going into the database again and again, right? So those are some of the thoughts that people have looked at, right? Yeah, so in that line, one thing that people can do is, people have done is, one approach is to partition the database into multiple partitions. And in that approach, what they're saying is we can do it with 2 database scans, right? So, I mean, you say 2 database scans, entire database scan is scanned only twice, right? So that's why, right? So first one, we partition it, and then rather than doing the frequent pattern mining on the entire data set, what we do is we do it in a partition, right? Each partition we do it, right? So, and then we take the frequent patterns that are identified in the partitions, combine them together, and try to check and see whether they are globally frequent, right? So because we know individual partitions, what are the figure, right? If a pattern is frequent in all 4 or 5 partitions, we can assume that it might be frequent, right? And then what we do is we do another global scan to confirm that these are actually frequent patterns. I mean, once we know what the pattern is, checking to see whether it's a frequent pattern is just one scan, right? But what identify what these patterns are is the biggest problem, right? So that's what we try to do by doing making partitions, and in other words, trying to do it like that. Another approach is to go for sampling, where, I mean, in data mining, typically we don't encourage sampling, but this is also an approach that we can take, where we take a small sample of the data set and then try to see whether we could, I mean, we could identify the frequent patterns. There's a possibility that we might miss some of the patterns because if our sample is small and that sample did not capture one of the key frequent patterns that are there. But this is also an approach where we do the frequent pattern mining on a sample, and then we check on the main database to check and see whether they are actually frequent patterns. Okay, with that, I get to the point where I would like to give a small break and ask you to do this Moodle exercise. And to do this Moodle exercise, you need to use the quiz password ARM1, right? So that's why I give it on this slide. Before that, let me explain to you what this exercise is. This exercise is asking you to use the a priori algorithm that I explained just a few minutes ago for this data set and come up. It might look like you're in Montessori or grade 1 and grade 2 counting letters in a table, right? But I highly encourage you to do it manually so that you get an idea about how this algorithm works, right? And also you can test yourself whether you understood this algorithm that I explained to you, right, just a few minutes ago, right? So, and remember, in this case, I would have preferred if one of you asked me that question, but since you did not ask, with respect to counting, if an item is present more than once, but still we count it once because we are actually counting the transactions. How many transactions? In how many transactions do we have this item? You might argue and say, if there are 2 pounds of bread in a market basket, that is more important than just one item. But in the basic ARM approach, in the basic algorithm, we only count it once, right? So remember that, right? So especially in transaction 5, we have COOKIE, and there are 2 O's, but remember we count it only once, right? And read the instructions very carefully when you enter the when you enter the answers to the Moodle, because my evaluation is based on certain pattern matching once again, right? So therefore, if you don't give the answer the exact way that I'm expecting it, it might not work, right? And if you have any questions, please shoot a chat message, right? Guys, take this as a break and try to do this. And yeah, I'll get back to you in about another 7 minutes, right? 11:20. Yeah, I do have a question. Let me answer that before I shut down. Not shut down, remove the slides. Yeah, the slide deck is also available on the Moodle, right? So if you want to go back. Yeah, good question. Yeah, so as I said, that type of thing can be done. That those are extensions to the basic association rule mining. Right? The question is asking whether buying two O's mean buying a C, right? So those can be done, but at the moment, the basic approach that we are talking about, we are only looking at from how many transactions are there, right? You are right. You are exactly right, right? So those are extensions to the basic way of doing it, right? So let's first try to understand how we do it in the basic manner, right? Yeah. There are papers people have written to do these types of things, right? Okay, so I'm going to switch off my video and then maybe remove the share also and also stop the recording.